First of all, let me say that I'm really very glad and I would like to welcome you all in this webinar. The webinar, which is the Earth observation in support of disaster resilience for the protection of citizens, economies, and ecosystems. This webinar is organized by the Disaster Resilience Showcase in the framework of the ongoing Horizon 2020 project eSafe. At this point, I should acknowledge the excellent work that has been done by pilot leaders, by the partners, and also acknowledge the important funding that we have received by the European Commission, so as to be able to run this huge project. And we are thankful indeed to the European Commission and to all of you for your dedication and the work done by the pilots. As a showcase coordinator, I'm really happy to work with you, and I look forward to continue this collaboration in the eSafe and in future projects. In this webinar, we attempt to bring together actors of the value chain from the Earth observation sector in using Earth observation data in the support of disaster resilience, and bring these actors, the value adders, with target audiences, including decision makers, key users from both public and private sector. At the end of the session, we will open an interactive discussion. We do like to see your interactions and hear your questions. And of course, you will be allowed to either submit your questions in chat or raise your hand and take the floor. Today, and according to the agenda, we will present the content and the work and the status of the 6 pilots that we have been developing in the framework of the eSafe Showcase Disaster Resilience. And these are pilots that are developed together through a co-design process with identified key users. And these key users, some of them, they have been also invited today so as to present their views and also speak about their experience from eSafe. To discuss also the way to move forward so as to develop further the ongoing applications, the ongoing pilots, but also to consider new pilots so as to widen the open the scope of the showcase to other disaster types. So considering different times and special scales, as well as pilot actions and other areas of disaster resilience. So before I start giving the floor to the main speakers, Alexia, I think we have to share with our dear colleagues a video from eSafe introducing very briefly into the eSafe project. So Alexia, please, if you could start the video of eSafe. Thank you.
Thank you, Haris. I will share my screen and the audio, and I will show now in full screen our video.
So after this short but very informative video about the SAFE project, I think we should start with the agenda of the day. I will give the floor to Ms. Lucia Mona from CNR. Lucia will present the activity developed in the framework of the Pilot Action 1 relating to the use of the Earth observation data for detection, discrimination, and distribution of volcanic ash. It's a very innovative and very interesting action for several users, and for this actually, the presentation of Lucia will be followed by a 5-minute testimony given by Ms. Tatiana Bulic, the Vice Chair of the Joint Unit Scientific Committee, Single European Sky ATM Research. So, Lucia, you have the floor. Thank you.
So, good morning, everybody. As Ari said, what I will present to you today is our activity as Pilot 1 into the disaster showcase, which are about how Earth observation data can be used for tracking and provide information on the volcanic ash distribution. Why this is important is because the volcanic eruption is clear to everybody that they can be a problem close to the volcano for having the ash there, and this can be a problem on many different aspects, but it is also an imminent threat for the aviation. And this is because the aircraft can have a variety of damages because of the ash inside and outside of the aircraft. And among these, there is a problem related to the engine that can have some failure during if ash is there while the aircraft is flying. And because of this problem, already in 1991, ICAO, which is the International Civil Aviation Organization, decided together with WMO to set up 9 centers around the globe, which are the VACs, the Volcanic Ash Advisory Centers, that has the mandate to operate, let's say, the surveillance of the ash distribution. And they should provide information 24 hours, 7 days per week. So they have the mandate to be operational, which is the situation in Europe. We have the VAC Toulouse and the VAC London. And it is recent the decision to have, under a risky situation, to have both of them working close each other in such a way that if there is a problem for one of the two, there is the other one as a backup. So they are officially handling 2 different regions, but then they can work together under risky situation for providing the service. And then there are also some supporting tools. I just put here 2 examples. There is the SACS website handled by BIRA, which provides satellite images related to such kind of eruption. And then there is this website from NOAA, where also the information related to volcanic eruption are available. So the question is, but there is still room for improvement. Why we are working on this if there is already such kind of organization? And there are known challenges about the current structure of ash monitoring during volcanic eruption. And I just listed here some of them. First of all, the VACs are updating their information every 6 hours. 6 hours is not really near real time. It's something that can request much more information, because 6 hours for the atmosphere is a long time. So you need to have something updated more often. Then VACs are also providing vertical information, but this vertical information has very low resolution, because they provided information just at 3 height levels, while nowadays are available Earth observation that can provide this information with a very tiny vertical resolution. Then VACS is also not providing information about the SO2 clouds. Why this is important? Because typically the SU2 clouds can be used as a proxy for the volcanic ash presence. And so it could provide additional information useful for monitoring and for handling the risk related to the volcanic ash. And then the model assimilation is not yet operational part of the back. And of course, model assimilation can improve a lot the level and the quality of the data provided by the forecast. So it's really important to include also this part in. And all these, let's say, deficiencies or pointed to be improved were clear during the 2010 volcanic eruption in Iceland, where also other issues were identified. We know in the research community that there are many data available, but these are not easy to be found to make it available to the users, to make it available to the pilots, which are the ones that at the end has to decide if they have to fly or not fly. And in a risky situation, it's important that this information are available in an easy way, in a clear way, and presented in a user-friendly way for the management of this risky situation. And what is still missing as important information is the vertical dimension. And this was explicitly asked by all the users that we contacted. So there is room for improvement. How we deal with? What we decided to have is to put together a consortium of institutions from CNR to CNRS, the Finnish Meteorological Institute and the Volcanic Observatory of Iceland and of Italy, for putting together all the important information collected by volcanologists, modelers, in-situ community, and satellite experts. So which is the idea? To put together all this kind of data. So data available at the source, volcanic observatory, ground-based observation, Earth observation satellite data, and modeling. Of course, we cannot put all the available data together, but the concept was to take the most from high-level partners that can provide data that are foundable and sustainable in the next future. So we decided to have data which are open data and to have models which are funded and sustained, and the same for the ground-based observation. To put everything together, integrate them in multi-source data and database, and to provide this data to aviation community, also tailoring them and making some innovation and doing everything with a user-centric approach. This means for us contacted a lot of potential users from VAC to civil aviation in Italy, aeronautics in Italy and in Greece, and different institutions like CESAR, from which Tanya will talk about later. Of course, this was not done from the scratch, but we built our system on the heritage of a UNADIX AV project that was an Horizon 2020 project. This is the list of the data that we considered. So we have AuroNet, which is a completely funded system and handled by NASA and by Actris. Then we have EarlyNet Actris, which is a research infrastructure, so as funds for the next 25 years. And then open data like Severi and MODIS and Sentinel-5P through the DS infrastructure. And then the observation, the volcanic observatories that have the mandates for collecting information. And for what concerns the models, we used two different kinds of models. One which is FlexPort, which is a transport model, and CLAM, which is instead an aerosol chemical model that also contains the possibility for assimilation. We had a very complex workflow. This is just a snapshot of the workflow for showing how complex it is, but the main concept is the following. We have the alert coming from the volcanic observatory, and this is, let's say, a trigger event that allows the collection from each one of the partners of the data. This data flow into a central server handled by CNR. And these data are so made available to all the others for the assimilation, for example, because this is really important, or for the initiation of the models. And all these data are organized and collected at this server, which make the data available to an external platform, which is the ADAM platform, where the data are visualized in a user-friendly way. And how we work and how we are achieving these results is working through exercises. We had the first exercise in 2021, in which we worked and tested in particular the data interoperability and how the different partners can read and handle the data from the others. And then we had an exercise a few days ago at the end of May, beginning of June, in which we checked the data generation in near real time and the visualization also in near real time. So let's say the readiness of the timeline of the data availability. Of course, there are still action to be done, and the few things pending will be done until the end of the project. We worked also on tailored products, and this is really important. This is an early warning system that we developed about the LiDAR data, and this is focused for the aviation. So what's typically collected by LiDARs are particle backscatter profiles, particle depolarization ratio profiles, and these are very important information, but these are not really easy to be understood from an external user, not a specialist. And so we developed this kind of product. I hope that you can see my mouse, the pointer. And this is an aviation alert product that show with different colors the altitude and time region where we observed niche content that can be problematic for the aviation. Different colors means different level of risk, with the red as the higher level of risk. Then we have still room for innovation, and recently it was done a work for investigating how much the model, the transport model flux part can be improved assimilating using the ACMWF meteorological fields, where the simulation of satellite Aeolus data for the wind are included. And you can see here, this is just for one case of eruption in 2021 from Etna. And there is a difference in the plume position if we consider the Aeolus wind assimilation or not. The Aeolus assimilation plume is the green one, the magenta one is without the assimilation. There is not a so huge difference in space, you will say, but there is an improvement. And it has to be considered that this eruption was a very faint eruption, small amount of ash was emitted. And so if for a small eruption, we see this big difference, think what you can have in a case of big eruption. So also this is part of our pilots, so looking for innovation. Then just I want to show you the ADAM platform where we ingested our data. So I will show you a video hoping that everything will work fine. So everybody can connect to the platform. The website is explorer.eshape.adamplatform.eu. And for looking to our data, you have to log in through the Meio login. If you are not registered, it's just a matter of few seconds. You have just to report information about name, surname, and email, nothing more. And then you can explore the data. So you can look, in principle, all the globe, and you can go there and search for data. So I will show you the example for an eruption on the 12th of March, 2021, which was used for the exercise. And I searched for Meteosat data, and going to the time of the eruption, you will see the data appearing.
Okay, yes,
Okay.
now we can see it, okay.
Okay, so I just want to show you I don't want to start from the beginning because, okay, so let's say starting from here, that is the search of the data through the platform. And yes, so you can, as I said before, you can search for the dates, you can search for the time. You will see here the point of and the box of Meteosat observation and moving in the time. You will see them. You can zoom. You can, here is how you can change the scale, because you can expand the data about Meteosat and you can change the opacity of the box. And you can change the minimum and maximum value for improving the, let's say, the contrast and so on. So I don't want to make you lose too much time, but yeah, just for, yeah. So here, this green dot is the starting of the eruption on 12 March 2021 on Etna. And then we have the plume moving. Can you see it? Yes.
Yes, yes, sure.
So you see the plume of SU2 moving over the Mediterranean and going toward the southeast, so toward Greece and flowing. And we can add a different layer, just adding more data, a further data set. And yes, this is a pre-recorded video just to be sure that everything is working and not the connection failing. So early data, attenuated base scatter, as I was saying before, are mainly the raw data from LiDAR. So providing information about the vertical extension of them. And yes, I will show you the Antikythera data. And so there is this window on the right that appear, so together with the other layer, and here you can see the vertical. And so searching for when the data are available, because not always they are available 24 hours per day. So you can see here, Antikythera is the red dot, and Meteosat showed that the plume is around there, the SU2 plume. Then some time is needed for loading the data. And you can see here that there is a signature. You can also change the scale for seeing different color scale. I prefer this one where it's more visible, and you can look at that and you have the layer. And you can add also the early warning product for the same time. And when you search for it, it updates for the same time. It's black, and this is because it is not recognize any kind of risk alert for this case. And this is because, as I said before, it's a very small eruption. And this is the reason why it is not an alert for the eruption. And this is also an important information, because sometimes there is a lot of chaos under the during the eruption, thinking for problems in the aviation. This happened also for the 2010 eruption. We were called in Italy asking for, is it dangerous for us? And also providing an information that there is no risk is an important information. So we are still working on some aspect of the platform for the visualization of the models, for example. Sorry. But we are in a good shape into the E-Shape project. And we are very happy for that. So this is everything I would like to show you. And really, let me stop my showing. It's I will thank you for your attention, and I will give the floor to one of our users, let's say co-designer, because Dr. Tatiana Bolic was so kind, and since the beginning, already since the UNEDIC's AV project, she followed us and our developments, and she was really important for helping us in developing our tool. And in particular, she is really important in the community, because she tried to link the research activities related to the aviation management and atmospheric fields about this. So thank you, everybody, and thank you, Tanya. Give you the floor.
Thank you, Lucia. Very nice presentation, and I can see that there's a lot of work that went into this, and what I like about this, about the atmospheric science is that, well, with respect to the research in aviation, in the air traffic management, you're moving much, much faster than we are. But it's also a little bit understandable because we have, since aviation is we are very safety conscious. So any type of change needs to go through a zillion and a half of checks so that we are sure that it doesn't impact safety in a bad way. And that's also where this research and this tool development also comes in handy, because it's really important also for safety. As Lucia said, we had there also in 2010 when we had a big trouble in Europe. Why there was a big trouble? Because, well, usually volcanoes don't erupt in bigger parts of Europe, especially where we have very, very dense air traffic like Central Europe. And as we are very safety conscious, the regulations in aviation say that if there is ash forecasted, so it doesn't mean it has to be there, it has to just be forecasted, you have to avoid that area. And if you remember, in 2010, the forecast was pretty much covering the entire Europe. So to err on the safe side, most of the states closed the airspace. So say, well, you know, these are our rules, we will follow the rules, right? In the end, we figured out that, well, the forecasts were not that good, but I mean, that's what we had, the tools we had, they were developed such a way. And then we've seen that over the years after that, there was a lot of activities, both in atmospheric sciences, and we can still see with Lucia and their group that they are also the E-shaped, the research is continuing and the models are becoming better and better, which is good. We can have then better decision making with those better models. What we were lacking was that the forecasts were not as good, because then, I mean, we knew that after 6 hours with the different meteorological situations, because the models that were used at the time were not able to take meteorological situation as it was evolving. I think they could take the meteorological situation at the moment when they first started, but not when it was evolving. So of course it was not that good. And it's not that it was completely wrong. There was ash all over the Europe, but maybe not in those quantities that we thought there were and that are dangerous to aviation. They're still maybe not dangerous, but they would still probably, if they allowed them to fly, they would have gotten them, then the maintenance would have been very, very expensive, because you still ingest ash in the engine. It cuts down the life cycle, so it increases the cost of maintenance. So all of that. So I like where this is going, because it's using more sensors, both from land and from the space, getting this. And I think, I guess you said, Lucia, right, that you are also talking to VAX, and they are I think at this point in time also, as all the information delivery in aviation is very, very regulated. So our first point of contact for volcanic ash information are VAX. We listen to them because all the procedures, you have to know that in aviation, we set the procedures because we need to, it's very fast moving and you need to have something that you know how to follow. So the first point of contact is VAC. They produce the information, then that of the forecast. Then that forecast is taken by the meteorological institutions of countries where this happens. Then they issue other, they're called NOTAMs, notice to airmen. They issue other things, or severe weather thing. So, and then based on that information, like where the ash is, at which flight levels, then that's based on that, the companies plan their flights. So it's a long process, and I have to tell you that it's at least once or twice a year the exercises are organized to see. to test the preparedness of both airlines, air traffic control, and all the other things to see that. So just because this is something that doesn't really happen often, right? So if something doesn't happen often, to be able to actually do something relatively quickly when it happens, you have to practice. And if you have better information, that becomes easier, because then we can probably also shave off of different constraints and maybe not need to close that big of an airspace or avoid the big portion of airspace and such. So good. And I think that VACs are going to take it, because I also know that VACs pretty much had their hands tied because they don't have too much budget for this type of thing. So they can't really work on improving it. They're pretty much, what I can understand it from the budget they have, is they just provide the service with the models that they have, and that's it. If they can use that, and then we have then you get also the visualization for other uses. That's wonderful.
Thank you, Tanya.
Thank you very much.
you.
Thank you very much, both of you. Thanks, Lucia, for the very good work you have been developing the last 3 years almost. And also thanks to Tatiana for providing us so encouraging messages, actually seeing that the developments and the activity that has been done by the CNR group and the partners is so well appreciated and used by air traffic management organization like CESAR. So if you have questions for our two colleagues, please, just keep them or write them down in the Q&A, or you will also, or you will take the floor later. So the next speaker is Mr. Dr. Antonio Parodi from CIMA organization. Antonio is presenting the power of GEOs actually in the support of weather disasters. We are very much interested to listen to the work done by CIMA colleagues and the partners in this pilot activity, and also to listen to the testimony of Ms. Silvia Puca, representing an authorized institutional organization, the Italian Civil Protection Authority, in regard to the support they have been receiving from this pilot activity. So, Antonio, the floor is yours.
Thank you so much. Good morning, Aris. Good morning, everyone. I will try to share my screen. Let's see if things are working fine. You should see my screen. Now I am moving the presentation in presenting mode. Yes, it is a very big pleasure to be here today to present the activities related to our pilot number 2, which is part of the activities presented here as Earth observation in support of disaster resilience for the protection of citizen economies and ecosystems. The work that I'm going to present is related, as I said, to the GEOs for disasters in urban environment. It has been developed in a close connection with the advice and the requirements provided by the Italian Civil Protection Department, which is one of the funding institution in 2007 of the CIMA Foundation, and with whom we are collaborating on daily basis for developing research and applied activities for civil protection. All the idea built around our pilot is basically focused on the attempt of taking the best possible from the availability of different observational data sources, first of all from remote sensing data, and namely in particular from Copernicus products, in support of early warning activities in a very special portion of the Earth planet, which is the Mediterranean region. We know it is very well consolidated literature that for a number of atmospheric and local morphological reasons, the Mediterranean area is considered one of the climate change hotspot, namely one of the regions where the impact of ongoing phenomena due to climate change will be more prominent. And despite all the effort in place in order to improve the early warning activities for those events, still there is a significant number of fatalities occurring and very severe socioeconomic effects. On top of that, also the very recent report from IPCC confirmed that the intensity and especially the frequency of heavy rainfall events and droughts will increase in this century in this part of the globe. So what we have tried to develop in this pilot is a stronger synergy in between aforementioned available observational data and the modeling tools that we have in order to provide better forecasts. Therefore, what this pilot enabled was the possibility of testing the ingestion into our hydrometeorological forecasting chain of different observational data, where we start from in our work, where we have different ingredients on the table and different keywords to be considered, in the sense that we have to be capable to execute rather complex numerical weather prediction models on high performance computing facilities in order to be capable to achieve fine spatial temporal resolutions necessary to try to catch the spatial temporal evolution of extreme events. Then, in order to go from the pure weather scenario down to the chain, to the impacts, we have to be capable to execute also another piece of the modeling chain, which is related to the transformation of the weather scenario in terms of rainfall, temperature, and the wind fields and so forth into an hydrological modeling simulation, basically into a discharge into a given cross section. And then we want to be capable to, in case the weather scenario is aggressive enough and the concurring hydrological scenario is resulting into a possible flash flood event, we want to be capable to propagate the information into hydraulic models in combination with floods and permanent water mapping. The final destination of all those efforts is a platform which has been developed out of the E-Shape project, but which is the natural destination of our results, which is the data platform developed by the Civil Protection Department. In this hydrometeorological forecasting chain, which is profiting of different observational data, Copernicus products for the assimilation to the hydrological model, land surface temperature and soil moisture from Sentinel-1, information from Sentinel-1 again for the floods and permanent water mapping. We are also profiting of other observational data like in situ weather stations, either from authoritative sources like the data from the Italian Civil Protection Department, or personal weather stations. So in the spirit of involving also citizen science data into the process. And last but not least, also other remote sensing data like the radar data provided, for example, by the Italian Civil Protection Department. In the development of the tools of this chain, in the integration of those tools into the chain, including Earth observation data, it happened certainly not under the control either of Italian Civil Protection Department nor of the CIMA Foundation, that one of the largest and more persistent extreme weather events in terms of Medicane occurred in the Mediterranean probably in the last 20 years happened. So what we try to do by exploiting the aforementioned data in close coordination in near real-time mode with Italian Civil Protection Department personnel, we basically try to test the potential performances of this system for such a very particular severe hydrometeorological event. What it is a Medicane? I suppose that it is mostly known by the largest part of the audience, but just like a very quick summary, the Medicane is nothing else than the synthesis of two pieces of words, Mediterranean and hurricane. And it is a kind of cyclone which is manifesting different characteristics along its spatial temporal evolution. Its own generation is the one typical for extratropical cyclones, which are very frequently observed in the Mediterranean region. But in certain particular conditions, this extratropical cyclone may evolve into phenomena which are very similar to the hurricane that we are used to see on news, on global scale weather forecast information, the tropical belts like Atlantic, Pacific, Indian Ocean. If you look at this image, which is the Mediterranean hurricane Apollo, who developed in between roughly 24 October last year and the 30th October last year. And you imagine for a second to remove the landscape corresponding to Northern Africa coastline and Greece, Southern Italy, and so forth, and you just focus on this shape, honestly, I believe that most of the people will say that beside the special scales, this is an hurricane. And the genesis in the Mediterranean of those phenomena is associated to strong temperature differences between the Earth's surface, understood like the sea surface, and the higher part of the atmosphere, and the evolution into a tropical-like cyclone is taking place when there is a very significant heat exchange between and moisture exchange between the sea surface and the planetary boundary layer. This is why the Sirte Gulf in front of Libya is one of the most Medicane affected areas into the Mediterranean. The Medicane cannot reach the severity of category 5 cyclones, good enough, but it can point up to category 1 hurricanes, which still means a sustained wind in 1 minute up to 110 or so kilometers per hour. And it is capable to pour down also significant amount of rainfalls. This Apollo case was particular for a number of reasons. The amount of rainfall, you'll see later listed on eastern part of Sicily and Calabria, which was very significant. And the fact that this event, instead of persisting, as usually it is happening for the Medicanes, 1 to 2 days, it was lasting almost 1 week. And this is a very strange condition because you know that an hurricane-like structure has very hard time whenever there are continental masses around. But this system was capable to move here and there in this area, exploiting the very favorable, due also probably to climate change, sea surface temperature in the region and the strong exchange in between the sea area and the lowest part of the PBL. Why it is also interesting to test what we developed in shape in this pilot for the future. Why? Because there are studies developed by CMCC, for example, the European Center for Climate Change Studies in Italy, that are estimating that the annual incidence of those events is the order of 1.5, and it is expected that this incidence is increasing by order of 15–20%, with the possibility, not yet confirmed by many studies, to have also intensity closer to category 2. What we did into the project? Well, we put in place our hydrometeorological forecasting chain, in particular the one on the right-hand side of the slide, and we performed a set of simulations in near real time provided by indeed another European project, Horizon 2020, Lexis, and this is also another value of partnership with another European funded project. And we performed simulations along the 7 days of the event on daily basis for the next 48 hours by assimilating in situ weather stations and radar data. And just to give you an example, this is for the 2 days most intense rainfall phenomena over southern Sicily and Calabria, in between the WRF predicted rainfall field and the observed one. The overall agreement is very good in terms of affected areas, southern part of Calabria and eastern part of Sicily. And it is good to know that this forecast was available basically 24 hours ahead the most intense part of the event. So well in time for whatever civil protection related action. But beside the A-ball comparison, it is nice to show, but I will do later, also the fact that being capable to assimilate high-resolution spatial temporal data and to run the model at cloud solving space, it is also possible to reconstruct in a very nice, interesting way the 3D structure of the event. This is nothing else that a vision from basically, let's say, Tunisia area of the system over Sicily during the most intense part of the event. And those orange-like colors area are nothing else that updraft, bringing water vapor towards the upper part of the atmosphere. And you also recognize a strong advection of water vapor in the lowest part of the domain. But more than a physical insight, what we were interested was to compare in real-time mode the performances of the model, which is the red color part of this map, and the observed one. You recognize that all in all, the agreement is very good. We capture very well the affected area. And the centroid distance in between the observed pattern and the predicted one is an error in the order of 10 kilometers, which is low because usually in meteorology dynamics, we say that we believe 4 to 5 times the model grid spacing, which is 2.5 kilometers. So we are really into the scale of the model reliability. The agreement is very high is testified by this function, which has to be closer to 1 if the model and observed agreement is very high. Where we have a little bit of challenges is in the spatial extent, in the sense that the model did map an extent of the most intense rainfall cluster larger than observed. But all in all, the agreement was kind of very good. Then what we did, we passed those predictions to a stochastic downscaling model, which translated it into an input for our hydrological model continuum. This model is capable to predict a number of very relevant fields for hydrological applications. And one of its strengths sits into the fact that it is calibrating only using satellite data. Surface temperature and soil moisture. Both can be provided by Sentinel products. So we did run this model, Sentinel data calibrated, and we basically provided the prediction in real time for the Italian Civil Protection Department. Those predictions, if I may very quickly do so, is available. I will try to jump on the fly on the platform. Is available, let me hit this guy, on the Deweta platform. I have to pass to Alexia the credentials, but this is the Deweta platform hosting the real-time products that we run in those days. And just to give you an example, I can, for example, present the hydrological model predictions for that day. It will pop up here, okay? And you see, like, the model 1 day in advance was capable to detect as possible evenly affected areas by severe flash flood phenomena, the Catania floodplain that indeed was the one mostly interested by the event. And if I click on the button, hoping that the network is helpful with me, you see that by using the 24 October prediction, we could have basically on the next 2 days a discharge prediction. And if I go back with time and I move on the 24 period, for example, you will see in a second. It is now. I will re-upload it. Okay, we should see in a few seconds here appearing the prediction that was available with the model over the most affected region, with a clear overpassing of the alert level. Coming back to the presentation, what we did was basically to in cooperation with the Civil Protection Department, to use those data to trigger a flash flood prediction by flood proofs. And flood proofs driven by the meteorological observation, including soil moisture from HSAP products, we could also estimate a return time later on of the event, identified like part of the Catania floodplain was interested by discharge phenomena with return time above 30 years, if not more. We didn't limit ourselves only to the hydrological prediction part, but we also passed the flood-proof WRF-driven discharge prediction to an hydraulic model, Telemac 2D, run on CIMA Foundation computing premises, to have an assessment of the hydraulic impact of this event on the Catania floodplain. This assessment allowed, for example, to identify, to have a mapping of the water velocity of over the Catania floodplain during the event, with rainfalls in the order of 1 meter per second or more, which is making very tough for people standing up, and also the water depth. We didn't limit ourselves also to use forecast products, but having an idea of the possible impact of the event in advance, also from an hydraulic point of view, enabled for CIMA colleagues in partnership and under the guidance and advice of the Italian Civil Protection Department, also to trigger on-demand mapping of floods and permanent water using Earth observation data. I say on demand because during the real-time exercise, we used the outweighed algorithm, which has been developed under the leadership and guidance of Silvia Puca, here present, and we could exploit not only Sentinel data, but because of a good relationship with the Italian Space Agency, enabled by the good quality of our weather forecast, we also exploited Cosmo SkyMed information. And all in all, what we could do was to work in a data fusion perspective, compensating one side the fact that, as we know, because of its own polar orbit, Sentinel has a revisiting time, which is good, but let's say sometimes challenging for civil protection purposes, and putting basically together the Sentinel-1 ascending and descending passes with the Cosmos SkyMed products, we enable the capability of identifying the flooded areas using Earth observation data. And while we don't have any direct control on the Sentinel data processing, and we did exploit standard products provided by the Copernicus services, in the case of the Cosmo SkyMed products, knowing in advance the meteo and hydro prediction, translating the hydraulic scenario, enhanced by in situ data and air observation data, we could, with a good degree of confidence, ask, in agreement with the Italian Civil Protection Department, to ASI, the Italian Space Agency, to execute specific acquisition for those purposes. And what we could obtain? Well, this is, for example, the flooded areas map obtained with AutoWade over the Catania city, together with the accumulated observed rainfall depth 24 hours before, referring to the 5 UTC 25 October acquisition. And you see here the flooded area. Then it was possible to, starting from this information, to use a flood water depth estimation tool enabled by a dam-to-meter availability provided by Sicily region, in order to identify, this is mostly crucial for civil protection, the water depth in each cell, and also to enable water speed information. Those data, pardon me if I do another jump back on the Weta platform, are available here on the platform. I will close this part. And for example, if I go here, I hope that I'm capable to hide a bit this part. For example, if I go here, I can select the Sentinel-1 B image collected on the 10 October 2005, more or less 17 UTC. And if I click on this map, I detect here the flooded areas, okay? And the same, if I come back on the platform, I can do for the Sentinel-1 A passes into the into the morning. I click here, and you see that I can switch on or switch off the two maps. This was the scene available into the early morning, and this was the one in the late afternoon. Okay, but the interesting thing is that in real time we could also exploit the Cosmo SkyMed information, which is, for example, available where it is, which is available here into the platform. Coming back to the presentation, by overlapping the Telemac to the water depth estimate, this purely driven by the modeling part, with the Sentinel-1 auto-weighed processed data and the Cosmos SkyMed processed data, we could have basically an overall picture of the flooded areas, which is very relevant for post-event assessment. Also in consideration that in this area, not only, let's say, people have been affected by the event, but the Catania floodplain is also very relevant from an economic point of view, because there are many relevant and very productive agricultural activities.
Antonio,
So, yeah.
Of course, it's very interesting all what you are presenting, but we ran out of time. If you could summarize.
Yeah, I am at the conclusion. I am at the conclusion. Sorry for the delay. So all in all, basically, I may state that we could use in near real time the services developed in the framework of this pilot, putting together different modeling elements, all of them exploiting a very rich portfolio of observational data, including Earth observational data provided by Copernicus, Sentinel data, but also Cosmos SkyMed from the European Space Agency. And all in all, I think that this has been both from a scientific, but also from an operational point of view, a good proof of the value of putting all those elements in a single chain for civil protection authorities. Sorry for running out of time. I will stop and I will leave the floor to Silvia Puca for additional thoughts, comments about what we did so far. So I'm stopping the sharing, and sorry again, Aris, for being a little bit late.
Okay, thank you, Antonio. Very interesting indeed. So the floor now is in Silvia. Silvia, the floor is yours.
Good morning. I work at Italian Civil Protection at the Natural Hazard Risk Management Office, in particular for the hydrological risk management. So yes, I can say that we had this collaboration with CIMA. In particular, I can say that during this event, it was very useful for us because they were able to provide us information on the forecast, so the meteorological, hydrological, and hydraulic forecast, and also on monitoring using different data. So as Antonio said before, unfortunately, as you know, we had in the last years an increase of severe events in the Mediterranean area, and that are related to storms, to convection, and often also to this kind of flash flood that it's really difficult to forecast and also to provide information to the local agency to make an alert. So what we have seen that is really important to integrate all this information together. And also, for example, in Italy, we have a lot of ground data because we have more than 3,000 of rain gauges in Italy. and more than 20 C-band radars. So we have a monitoring of precipitation in particular with a very good network, ground networks, but Italy is also the country of the sea, of the coast. So we need to monitor what is happening out of the coast of the sea and to understand how is evolving the events that generally born in the other part out of Italy and often in this over the sea. So if we have this kind, when we have this kind of events, we need to provide to make an alert in very short time. And we can do only if all the information available are integrated very, very soon and are input directly inside the meteorological model, and the meteorological model directly in hydrological model, and then following in hydraulic model. Because in this way, we have very soon a complete view of what is happening, what will happen in the near future, so near casting, and also which are the main effects that we expect over the land and so in our cities. So I see that I can say that really in our work, this can make the difference, because when we have this kind of information, we have short time to make alert, short time to advise the citizen, the municipality, and the local agency. So all this kind of information and model have to speak with others, and in this way can have a complete or more complete possible view of what is happening and the effect. So I think this is the main point that we have observed with, and we are observing in the last years also with the collaboration of and support of CIMA.
Great, thank you very much, Silvia. Thank you very much, Antonio. It is impressive indeed. I mean, the platform, I know the platform, but I think anytime that I see it again, I understand that there is a lot of improvement. And it is indeed very important that having such an important user on board and co-designing, as I can understand, the platform together, I think it's important that we could consider the possibility of transferring this capability or this innovation actually into other neighboring regions. Maybe later in the discussion, Antonio or Silvia, you could elaborate further on this question. And now I do pass to the next presentation, which is given by Pablo Esquero from EuroGeoSurveys. Pablo and the team is dealing with another area of disaster, which we classified in the so-called geohazards. And this pilot is exhaustively using Earth observation data together with other data, always coupled the information data with other data, so as to assess the impact of surface displacements into the cities, into the built environment, and the critical infrastructure. Pablo, better to give the floor to you to present your activity and to be testified again, of course, later on by Mr. Jose Manzano Cerro, as I can, if I did well, from the Secura River Basin. Thank you. Pablo, the floor is yours.
Thank you, Haris, and good morning to everybody. I'm going to share my screen here. Okay, so our pilot is focused on the use of Sentinel-1 data, especially all kind of radar data, but especially Sentinel-1 data, in order to assess geological hazard vulnerability of urban areas. In this way, the geohazards are very different. We have landslides, we have volcanic activity, we have subsidence. They affect very different regions and also remains a few days in time, like for example a volcanic eruption, or many years or hundreds of years in the case, for example, of landslides. Since this is a very difficult hazard to assess because of these reasons. And in this pilot, the idea was to develop tools in order to help the geological surveys to deal with this kind of hazards and provide products that can be useful for the final users. Now, the objectives of the pilot were to increase the use of multi-mission, but focuses on the Sentinel-1 data, the products and the services to assess this urban vulnerability related to geohazards, and map the vulnerable areas and critical infrastructures that could be threatened by these geohazards. The idea is to raise the early awareness and train the key users and the decision makers in order to improve the use of these products, especially for the urban resilience against these geohazards. The users, minimize this, okay. The key users are the urban planners, the policymakers, but also water management operators or insurance companies, civil protection, all the people involved in the geohazard community. The products that the pilot have designed are four. There's the first product is the insert processing, is the more technical product because it's just the result of process large stacks of insert images. The second product is the insert validation report because it's very important, especially in areas that have not been analyzed previously, to validate this insert data, especially with in situ data. And the third and fourth products are the products more related to the specific test site, which are the active geohazard areas, is the definition of the geohazard and the analysis, spatiotemporal analysis of it. And the last product is the detection and analysis of urban vulnerability. Since the geohazards, as I said, are very different one from another, is it impossible to provide a general product for everyone? So the idea is to provide an on-demand product focused on test sites. We have at this moment carry on three specific test sites, one in the Segura Basin, one in the municipality, and one in the Silesian Coal Basin. Today I'm going to present two of them. One is related to groundwater changes. This is the common municipality, which is carried on in collaboration with ISPRA team, and with data provided by the CTTC, which is an Earth observation provider. At this point, we have the insert processing product. The validation product in this area is going to be difficult due to the gap in the in situ data in order to validate the results. But we are still working in the other two products, which are the active geohazards and the urban vulnerable areas. In the Silesian Coal Basin, we have processed two data sets using two online cloud computer systems, which are provided by the GEPTEP platform. These are the PSBus tool and the FastBell tool. With those datasets, we could validate the results, do a validation of both of them, and then carry on the active geohazards product and urban vulnerability. In this case, the problems are related to mining activities. Well, very fast description of the products. The first, as I said, is the insert processing. This is a quite complex product that can be provided by an Earth observation data provider, or can be processed by the geological surveys using their own capabilities, or, for example, these tools provided by the GEPTEP platform. And now the European Ground Motion Service has been released, not in an operative way yet, but I think it's going to be available at the end of this month. This provides European cover of displacements, and if the results are adapted to the process that is happening in an area, be the first part of the analysis. These insert results are usually high dense point clouds, which can show a clear deformation area, like in this figure, or can only show small and slight displacements. This is very important because in order to analyze the results, the identification of the display of the deforming area must be clear and must be done by experts in the insert technique. The results in the Silesian Coal Basin, for example, are, as I said, obtained using Sentinel-1 data and processed by FastBell and PSBus tools, and show clear deformation areas over the mining districts. The case of the common municipality, for example, we cannot see a significant deformation in the main product. Here is everything is more or less stable, and the time series show a general stability. But if we focus on the harbor of the lake, we can see that some points reveal declining trends, for example. In this case, the urban area is affected by groundwater anomalies related to the Combo Lake level. The second product consists of a methodology of validation that can be divided in 6 different levels. 3 of them are quantitative and 2 of them are qualitative. In the case of no in situ data can be available in the area. With this methodology, we can validate the insert data in order to provide a better estimation of the geohazards affection. For example, in the Silesian Coal Basin, we have cross-validated the insert data, and using a partial validation based only on the displacement velocities. And a good agreement is with a root mean square error under the thresholds, the stability thresholds of the area. This report is provided to the final user in order to give them more information about the data and the problematic that could be related to a good or a bad validation. The third product is more focused on each specific test site. with 3 parts: the geostatistical analysis of the data, the identification of active deformation areas, and the main geohazards analysis. The product 3, or post-processing of the data, is the geostatistical analysis in order to define these stability thresholds. After that, we can select the active areas in order to focus on that areas, not all the processing. And if some extra data like geological data, mining areas, or let's say, for example, the position of the aquifer systems, a pre-analysis of also, for example, the DTM to derive the slopes of the mountains, we can even perform a pre-analysis of the main geohazards of the area. With this, we can perform the product 3, which is the definition, the analysis of the geohazard. In this case, I can show an example of the Como Lake, where we can see that near the lake, the piezometrical levels shows a slow decline of the levels, and also the displacement can see this small subsidence. So we can perform this kind of analysis. For example, in mining areas, in the Silesian Coal Basin, we have done an spatial analysis, trying to relate the subsidence with the active mining areas with the agreement, and in the temporal part of the analysis, we can see, for example, that in some districts the extractions, the coal extractions, remain stable during the years, and we can also see that the displacement trend is it's quite stable also in a declining trend. But in other regions where the extractions stopped, the subsidence also stopped. We have detected 10 districts, trend mining districts with this continuous trend, 5 with acceleration, 9 with an stabilization trend, and 3 which are anomalous. This is a very important information for the final users, because they can understand what's happening and what could be the future of the area. Last, the vulnerable areas, urban areas product. Take advantage of other auxiliary data like catastrophe data or damage detection campaigns to provide, if all the information is available, the damage probability related to this geohazard using the fragility curves method. But in the case that this kind of data is not available, because usually the damage detection campaigns are not available, we can perform the other level of analysis using specific data of the case study, defining thresholds to evaluate and sonify the vulnerability of each building. In this case, in the Silesian Coal Basin, you can see that we have sonified in 4 different types, and we can give the final user the number of buildings, the number of square kilometers, or the areas that could be more affected by these geohazards. As I said, this is an on-demand product, and the idea of the pilot is to provide resources to carry on all this analysis. The general methodology cover all the types of geohazards, but we have also specific parts in order to adapt it to the different geohazards, and also to help the geological surveys and the final users to provide the service and understand the products. For example, these are the admission questionnaire, who helps to understand if a test site could be a good candidate for the methodology. Also the data requirements and the co-design methodology to help the geological service to interact with the final user. And also, for example, the validation methodology, the pre-analysis tool, and specific methodologies for each geohazard. Also, the results can be uploaded to a map, to a platform, which make easier for the final users to interact with these results. The idea of the pilots is that it can be very adaptive to the necessities of the final user. And this is a fast overview of the dissemination results of the pilot, some papers, some participation in major conferences, and other participation in webinars and symposiums. This is all from my side. I'm going to share with you the platform where the results can be seen. Let me change the visualization. Okay. So here you can see the platform. The platform is named EGDI, and here you can see that, for example, the products in the Segura Basin. Can go through there, or with the opacity of the layer. This is the influence area of the well fields. This is an structure, water and groundwater extraction area, where subsidence related to that extractions happen in some drop periods. And here you can see the influence area, which is very important for the Groundwater Management Authority in order to know the affection to the possible urban areas. And other example in the Silesian Coal Basin, this zonification that I showed you in the presentation. Here you can see the results over that area. And it's also important to see if there is urban areas affected by the land subsidence, which could be the effect. And also because the geohazards can be very different one from another, you can add other WMS layers, for example, a perennial land cover or a landslide inventory, in order to improve the visualization or improve the analysis. Here in the platform, you can also download the associated data, like the co-design procedure or the data requirements, the questionnaire. Everything is here in the platform. And last, I'm going to present the testimony of Jose Cerón, who is who belongs to the Groundwater Management Authority of the Segura Basin here in Spain. They have been working with this data, and they give us the opportunity to be the first test site and develop the methodology over that area. I'm going to share the video of their participation. Let me here. Buenos días, José Manzano Cerón de la Confederación Hidrográfica del Segura va a contarnos la experiencia en la vega media y baja del Segura. José, ¿cuál es la situación de la vega media?
Hola, buenos días. Pues nada, la vega media es una zona que está encajada en un valle y sobre todo es una zona muy árida que tiene grandes necesidades de agua. En esta zona, pues se ha visto en varios periodos de sequía, sobre los años 94-96 y 2015-2019, la estrategia que se hizo para mejorar digamos, el aporte de agua a las zonas de regadío, porque es una zona que tiene bastante zona urbana, o sea, está la ciudad de Murcia y las pedanías que son bastante grandes y también la zona de cultivo bastante extensa. Y lo que se pretendía era ordenar un poco el tema de las extracciones de agua para época de sequía. ¿Qué es lo que se hizo? Se hicieron durante los años 80 y tantos y 90 unos pozos de sequía que se denominaron baterías estratégicas de sondeos. ¿Para qué? Para paliar el déficit de agua cuando ocurría estos periodos de sequía que son recurrentes en la cuenca del Segura. Y estos pozos, ¿cuál fue el criterio? Pues intentar colocarlos en zonas donde hubiera una mayor posibilidad de extracción de agua y que afectara lo menos posible a la zona urbana. Sobre todo a las construcciones, porque de todo es sabido que hay una correlación entre la extracción de agua y la subsidencia del terreno. Y en este caso se pudo comprobar gracias a las técnicas que se utilizaron. Primero empezamos con una topografía de precisión con GPS de precisión, luego con técnicas INSAR, en las que intervino el Instituto Geológico, sobre todo en el año 2018, que nos vinieron muy bien. ¿Y qué es lo que se pretendía? Pues un mejor conocimiento de la zona y sobre todo ver las posibilidades que había para no afectar a las construcciones, que era lo que más nos preocupaba en ese momento. Y por eso durante esa época se pusieron en marcha solamente los pozos que estaban lo más alejados posible de las viviendas, tanto de la zona urbana de Murcia como de las pedanías, y se pretendió, pues bueno, hacer digamos, un control y un seguimiento de eso. Uh-huh.
¿Y cómo ayudaron los productos generados a la Confederación para este?
Bien, pues lo que hicimos fue hacer un seguimiento exhaustivo y un control de las extracciones. Nosotros, digamos, los requerimientos que se habían hecho antes de empezar la extracción de los pozos era comprobar los niveles que había del agua y poner un umbral mínimo en el cual separaría el pozo caso de que se bajara ese nivel de piezometría. De forma que teníamos asegurado digamos, el que no afectara a las viviendas, la subsidencia. ¿Y qué se hacía? Se hacía un seguimiento de esa subsidencia durante las extracciones y luego se pudo comprobar que había una correlación entre cuando había una zona, o sea, una época de extracción y la subsidencia del terreno. Y sobre todo, ¿para qué se hizo eso? Para prevenir en las zonas urbanas, está claro, y las viviendas. Digamos que era lo que más nos preocupaba en ese momento. Y si se veía que había alguna afección, inmediatamente se paralizaba la extracción. O sea, porque los datos eran en continuo y vamos, que había una agilidad muy grande entre los informes del IGME y el seguimiento y la relación que teníamos con ellos. De forma que prácticamente casi en tiempo real podíamos tomar decisiones para parar los bombeos caso de que se pudiera ver una afección o una posible afección.
¿Y qué otro tipo de análisis o de datos serían interesantes para el futuro del análisis de la cuenca y mejorar esa gestión del acuífero?
Bueno, gracias a estos estudios se pudo comprobar cómo estaba focalizada la subsidencia en varias zonas. En la zona de Beniel, en Telesparragal y próximo al casco urbano de Murcia. Y digamos que eso se debería de completar comprobando en función del tipo del terreno la subsidencia diferida, o sea, sobre todo en las capas profundas. Pero solamente ese estudio en las capas superficiales. Y habría que ver si eso afectaría, si hay una subsidencia residual y si habría un poco de ver cómo responde a la subsidencia diferida en las capas profundas. Es lo que yo creo que se debería estudiar y ampliar los estudios y las mediciones.
Pues muchas gracias y hasta luego.
Gracias a vosotros. Adiós.
Thank you, Pablo. Thank you, Jose. Very interesting presentation and interview. I should pass to the next presentation. The fourth speaker of the day is a NOAA colleague who is coordinating an active and very productive pilot action for rendering agricultural ecosystems resilient to weather disasters. And also Ms. Chryssa Papagiannouli, representing or working in the insurance sector. It will give her testimony on about the views of the sector, insurance sector, actually, in regard to the benefits that received out of this pilot activity in rendering farmers, food, and agricultural ecosystem resilient to disasters. My dear Nikos, the floor is yours.
Thank you, Haris. I hope you can all see my screen. As we are running a bit late, I will attempt to keep things straight and simple with little to no technicalities. Still outline some notable services we've been developing recently under Showcase 6 Pilot 4, ResAgri. And my main focus will be the user-centric approach that we have and the interaction with a big amount of users we had recently. So it has only been a few years since the majority of research only got a chance to be applied out of pure luck. In most of the cases, it was a matter of a final report that was delivered within a project and rested in a drawer of an institute or a university. And only if someone from the industry had an appeal in this specific topic, it had a chance to be applied. So in our case and this project specifically, it was decided to inverse this top-down approach and adopt a bottom-up instead. We developed services according to actual user needs in order to produce services that would be useful by definition. Upon this approach on the precision agricultural services that we focus upon here in this pilot, we managed to expand from one sector, which was agro-insurance sector. Our initial end user was an insurance company, expand from that to 3 distinct sectors, the needs of which we accommodate. These sectors are the agro-insurance, as already stated, the farmers' cooperatives that we met along the way, and the industry related to agriculture. In agro-insurance sector, we have Inter-American Insurance Company as our main end user. And what are the operational needs of Inter-American? They first need to be able to tailor insurance costs according to the underlying risks associated with each agricultural parcel, instead of offering a flat rate over a region, which is the current default. In order to make this happen, we analyzed 40 years of satellite retrievals, ECMWF numerical model reanalysis. We fused them with a damage record received from ELGA, which is the public authority for insurance that the Greek farmers are mandated to use, and we made it happen for them. They also needed to identify areas that are beyond doubt distracted after an incident, so that the farmer won't have to wait 5 to 6 months or a physical evaluation from an agronomist expert in order to proceed with the payouts. The Sentinel-2 satellite imagery is available every 4 or 5 days. So if on consecutive passes, the vegetation indices are steadily low, like for instance, on a recent storm, it happened a few years back, the farmers should get reimbursed quickly and maybe be able to reseed if it's still early on in the cropping season. An early warning system also was necessary in order to estimate microclimatic features on a highly localized scale and not merely on a regional scale. We have set up an operational numerical weather prediction model running daily with over 1 million grid points over Greece, providing this kind of information in order to consult their clients accordingly. And finally, they have had some cases where a client applied for insurance only a few days before an extreme event approached, and they needed to be secure from similar practices. So we built a tailored service where they can upload an Excel file with just the list of the parcel LPIS coordinates under consideration, and it produces a user-friendly color-coded matrix that denotes if it's safe to proceed with the specific contracts or not. Next on the list are the farmers' cooperatives. We reached out to farmers themselves and provided our services free of charge until the end of the project in exchange of data like parcels and yields that normally should be allowed to access openly from public bodies, except this isn't always the case. We collaborate closely with Orchomenos Cooperative for Cotton and Cooperative of Thessaly Tomato Producers Thesto, both of which are very active and highly engaged. Chryssa Papayanouli from Thesto will present later on today as a user, so you will have a chance to hear her point of view as well. And we focused on these two crop types that have critical seeding conditions. Cotton crop needs to have specific ground or soil temperature in the first 10 centimeters and does not care for air temperature that much. Tomato, on the other hand, is already a plant during seeding, so it's critical not to have late spring frost episodes during this early stage. In 2021, in April, such a frost episode destroyed the whole production. Both are accommodated by our forecasting model in combination with artificial intelligence algorithms that daily denote subregions that are safe to seed, both in Thessaly and in Boeotia. The feedback for this service has been praising for the accuracy of the service, with field measurements being steadily on par with the forecasted values. Actually, a few days ago, we discussed with Chryssa because there had been some hailstorm events, and our indices, indicated this. Next, irrigation and fertilization are both weather-dependent activities. So on a parcel scale, we produce meadowgrams for 2 and 10 days with clear thresholds for each crop type specifically, in order to make it easier to take necessary actions. The farmers of Thesto Cooperative for Industrial Tomato can access this information directly through the cooperative's in-house service without the need to even go and search for their parcel. They just click a button and get a forecast through the horizontal linkage we have set up. The phenological stages, which is something that is developed from our colleagues in NOAA under Showcase 1 Pilot 2, is provided by them, is in simpler words the specific stage of the crop that it's currently at, and it's essential for necessary actions such as the application of growth regulators. For instance, cotton needs to be applied with a PIX regulator that stops growth when squaring stage is reached. These plots depicted here are from the same satellite retrieval on the same date and neighboring parcels. And based on the estimations of the AgGrowth system, the top parcel was at nearly 40% leaf development. The bottom one was at 79%, which were fully confirmed from field measurements. last is the agro-industry needs. Users from the industry such as Corteva Agri-Science that specializes in seeds and pesticides, John Deere tractors or Nomikos tomato factory have different needs. They are after showing maps for more regions. We have recently expanded the collaboration with Corteva to exclusively provide showing maps for cotton in numerous regions over Greece, as well as more crop types. Rice is next on the list. And they are also after the conditions that demand the application of pesticide. Our groups have focused on a type of worm, green worm, which we monitor the population in specific traps and then juxtapose them with our forecasts, and first results appear to be quite promising. The yield estimation, again, this is something produced by Showcase 1 Pilot 2 on a collaboration with us. We provide the necessary meteorological aspect on that. And the application is that factories of industrial tomato, for instance, need to know what to expect and when to expect it. They even provide higher prices per ton when the production is delivered early on or late in the season. And we are able to estimate the expected production months before the harvest, judging upon the meteorological conditions that have preceded until that point, as well as the evolution of reference parcels during previous cropping seasons under similar conditions. I have a plot here that denotes that if the farmer delivers early in the cropping season or later on, he or she gets a higher rate. And our services are very useful in that aspect under the idea that you need to have a calculated risk in order to take advantage of those higher rates. Because if you plan to deliver later on, for instance, we have the early sowing maps already mentioned. And if you plan to deliver later on in the season, tomato is very sensitive to heavy precipitation events. So in case a heavy precipitation event is in the vicinity and you are at, let's say, more than 90% of your crop development, you can easily, speed up the harvest, because if the ground gets damp, there are big trucks that cannot easily access the parcels in order to retrieve the tomatoes. So the farmers need to know about this, all these aspects, if they are about to take such a risk, looking after a higher rate. And last is the John Deere tractors are equipped with sensors that map the production in intra-parcel scale while harvesting. And this is very important for us because with the 10-meter resolution of Sentinel, we are able to denote areas of delayed growth due to a number of reasons like irrigation faults. For instance, you see here in that parcel, there is a part of the parcel that the crop is evolving slowly, and this remained as such even later in the season. Since we have ground data on intra-parcel scale, we can now evaluate all these aspects and further enhance them. And the take-home message from all this is that none of this or very, very little of this would have happened if we haven't reached out to all these users and helped each other towards co-designing and co-developing all this project, not only as a fancy term in the start of the project, but in real life. So that's all from me. I will stop sharing here. You can access the platform through resagri.eu, our main platform. And I will stop sharing and invite Chrissa Papayanouli from Thesto Cooperative for industrial tomato to share with us a few words.
Hello from me. So let me share my. Do you hear me?
Yes, Chrisa, we hear you well.
Okay.
You have a small presentation, right?
Okay, thank you. Thank you very much. So I am from agricultural cooperative of Thessaly tomato producer, which is called Thesto. And before I tell everything, I would like to say some words about us. That Thesto was founded in December 2012 in Larissa by 331 founding members. It was the natural continuation of the industrial tomato producers group of us Larissa in a Thessalia independent, sectorial and cooperative format. Today, we count over 600 members, which is 500 in the industrial tomato sector, and 100 is in the legume sector. We represent over 30% of the productive potential of the industry in industrial tomatoes. We are by far the largest organization in the field of industrial tomatoes and one of the largest fruit and vegetable producers organization in Greece. So, strong and long-standing desire of farmers to know in advance the possible weather conditions for the planning of cultivation work. Undoubtedly, the role of the weather is important for agricultural production. It's a contribution to all strategies of crop development as well to their yields in crucial as it is directly related to the emergence of pests and diseases, water needs and fertilizer requirements. In addition, due to extreme weather events, large-scale damage to crops can be occurred. So, agronomic strategies have been developed to deal with changing water conditions. For example, the delay in the beginning of the growing seasons can probably be addressed by choosing different varieties of plants. However, once the growing season begins, resources and technology are committed. And the only options left is to adopt cultivation practices that will minimize the effects of the dangerous weather events, with an important factor being the early warning of the occurrence. Clearly, medium terms weather forecasts with a period of validity that allows farmers to organize agricultural activities to cope or benefit with forecast weather conditions are useful. Of course, people not control the extreme weather events. However, having a timely to valid prognosis can help to adjust or mitigate their harmful effects. So here we can see the first page of our site. All the members.
Chrisa,
Yes?
Chrisa, sorry for interrupting. If you need to show the platform, you should enable share screen. It hasn't been enabled now.
No, maybe we will see that. Is that okay? Do you see that?
If you need to just describe it, there is no worries. But if you need to show something, no, we cannot see your screen currently.
As we did in the test before. Sorry for the Greek. Χρύσα, όπως το κάναμε στην αρχή, πάτα αυτό που το κουτάκι που ήταν δίπλα στο ρολόι.
Okay.
Και πρώτα, και βάλε αυτό το πράσινο το κάτω που λέει share screen. Πάτε το κουμπί κάτω.
Δεν το βλέπατε. Sorry.
Το κάνω.
Συγγνώμη. Sorry. Λοιπόν.
Μπράβο. Τέλειο.
Great.
It's okay?
Great.
Okay. So, let's go behind. No, here it's the portal. It's sorry, I lost. No, sorry. It's my first presentation in that way. So here you can see that it's the first site, the first page of our site. All the members have the access to Thesto Gate. So if someone click here and test the store gate, like a portal, he goes in this environment. The name of our farmer is Kostas Batellas. There are here many information for him and for his cultivation, for yields, and everything. It's important for him and the relation with the cooperative. So in our program, our farmer, he goes to this place, and he can see all the fields. Here, Kostas, our farmer, has three fields. Who has had in a village which is called Filia, in the location Tragana. The hectares is about 303 hectares, and there are many other information about his variety, the quantity of plants which needed for planting, the week of planting, and the nomikos is called the industry, which he tell us that he wants to go to deliver his production. And about our cooperation with Beyond is that our farmer Kostas, if he clicks here, he can see his farm from the Dorforos, I don't know.
From the satellite, yes, her satellite image.
Yes, from the satellite, and there is he can hunt weather forecast 10 days and 2 days for weather forecast. He has the opportunity to see the air temperature at 2 meters, the surface temperature, the wind speed. The wind speed is important for him because if you want to organize the application spray, and the relative humidity is which is significant for him to be aware for fungal diseases. And the rainfall of the following days is important for him because if he wants to irrigate his farm, he try to arrange his irrigation the quality of irrigation, which depended from the rainfall, what it is expected, and the others are very very important for him. Nikos explained that better than me, but
yeah, I need to mention here that we were in contact during the previous days,
yes,
where there have been many atmospheric instabilities in the vicinity, and I was actually surprised when we first discussed with Chryssa to learn that the farmers were very engaged in terms of weather forecasting. I said maybe it's too technical information for them, but they ended up asking me microphysical properties within the one model versus the other model, and we see WRF and how is it going against Cosmo, and I was surprised. So there are some indices like the Cape Indices that denotes you know, a chance to have a hailstorm or not. And during the last week, it exceeded the threshold within many days. So Chryssa called and said, Nikos, do you think this is indicative of a hailstorm? And I said, there is a big possibility, yes. And actually it ended up, you know, many parcels were hit by hail. Thankfully, not to an extent that completely, you know, distracted the whole production, but it was good to know, you know, hail is a parameter that you cannot do many things, but all the other parameters like temperature and wind and everything, you can take countermeasures in order to remediate, you know, their actions.
But if we expected the possible if we expected the hail in our farm, we can do preventive spray. So it's a good tool for that for us. Just to prevent, just to protect our cultivation from fungi. So, and at the end, the useful tools that comparative the useful tool for comparative producers will be leaf area index, soil moisture, sunshine and exhaust data of selected stations, drought bulletin, and then estimation of final production using algorithmic models. That is something which we are working together with Nikos, and maybe we will try to do that for the next times. So, and thank you for your attention. Thank you.
Thank you very much, Chryssa. Thank you, Nikos. Thank you both, and thank the team also for doing such an important. This is actually a very good example for one hand the co-designing with such involved, strongly involved user like the store. In co-developing things that are useful. Of course, it is interesting to see, I mean, what Nikos said about the interest of the farmers, actually, that, you know, the young generation of farmers is not like previous ones, that they do need to have access to innovative tools to get better informed daily, I mean, for their production, for their the sustainability of their production in any case, so that it's good. And so again, thank you very much. And also, Nikos, we should at that point thanks also the other group of NOAA working in the pilot, pilot 2.
I mentioned it, yeah, a couple of times because
such a merging of activities, right, which is of course very much promoted in shape. Actually, we want to have the fusion, the osmosis, to use a Greek word, in between the different pilot activities. Thank you very much indeed. And now, because we run out of time, I think I should directly pass to the next presentation. Actually, the next two presentations are from two newly onboarded pilots in ISAE. So we start with the presentation given by Marco Folegani from NEO company. Marco is dealing with the so-called FRED system, which is a flood risk and impact assessment system developed through the automatic change detection of Sentinel-1 and Sentinel-2 images, and it will be followed by the presentation of Mr. Omar Barilero, the project officer of SATSEN. Marco, the floor is yours.
Yeah, thank
you.
you.
Let's try. You know how it comes. I mean, the last speakers, they always try to be in time, but to keep the time frame. But okay, please go on.
Okay. So can you confirm you are seeing my slide? Yeah.
Yes, sure.
Oh, thank you. Okay, so yeah, I am Marco Folegani, and I am coordinating the pilot friend, which is, as Eris said, flood risk impact assessment through automatic change detection of Sentinel-1 and Sentinel-2 images. This presentation is structured in 4 sections. First, general introduction of friend. Second, short demonstration about the platform. The third one, next steps, evolution. And the fourth is the testimony as announced by Aris. First of all, what is friend? Friend is a project in the domain of disaster management. The main scope is to exploit as much as possible satellite and Copernicus product for impact analysis and risk estimation for flood detection. The consortium is composed by NEO, which I represent, Italian company operating since 2004 in the field of Earth observation application, and SATSEN, you know very well, European Union Satellite Center for Analysis for decision making. First of all, I have to say that FRIEND is mainly addressed to analyzing monitoring flood events, especially for those areas that are exposed to such kind of event, that are remote, that cannot count on infrastructure and advanced system as we know in Europe. Let me give you an example. Maybe all of you knows about Venice. Venice is exposed to sea level anomalies, but Venice can count on alert system and protection system that can prevent severe damages. Other parts of the world are exposed to less severe sea level anomalies, but they are more impacted with more damages. And this is because there are areas in the world that cannot count on advanced system like alert, like protection system, and so on. So this is this represents the user community we are addressing with our service in presenting this pilot. But first of all, FRIEND. What is FRIEND? FRIEND is based on 2 mature components, which are the geodump pipeline provided by SATSEN, which is for elaboration and analysis of change detection based on Sentinel-1 and Sentinel-2. The scope is to fuse together these 2 kinds of products to generate advanced map change detections from high resolution satellites provided by Copernicus. The second pillar of FRIEND is the platform Adam. You have already seen an example, an instance of Adam in the first presentation. This is an instance customized for FRIEND, where we can put together some data sets coming from Copernicus, not only for what concern the risk data sets for flood monitoring. The idea in FRIEND is to evolve, is to put together these existing technologies to create a unique service, which is a customization of the components that will be deployed on Creo DS. How Friend works, the concept of the service is pretty simple. We are addressing two categories of user. The first one is a generic user, which is supposed to be expected to provide us specific requirements in terms of area of interest, period to be analyzed, and parameters that need to be monitored. The team of Friend analyze, identify, select, and filter those datasets that are particularly indicated for the kind of hazard we are going to monitoring. Then the elaboration of the products starts, involving the components provided by Neo and Sachin, and the results and the service is exposed on the front end that we'll see later on in the demo section. The expert user category can count on the backends of Friend, which is mainly based on Jupyter Notebook, where the expert users can exploit the API and the products and the algorithm to run by themselves the processing and to extract the final product that can be then exploited and proposed to the generic user. The chain detection is the first main product proposed by Friend, which is based on the GeoDump pipeline developed by Sachin. The scope of this pipeline is to exploit as much as possible the combined capability of monitoring of Sentinel-1 and Sentinel-2 in chain detection. Indeed, GeoDump is able to provide single platform chain detection, Sentinel-1 and Sentinel-2, but also the fusion of the two products. The idea is to automatize as much as possible the process and to provide an API to run the change detection algorithm. The front end of Friend is mainly based on area of interest. This is a service that is not addressed to a large area of monitoring, but to a small area and where the flood events are impacting during the time. The idea is to aggregate specifically for use case different kind of data sets under two main categories, which are the flood risk and the flood impact. The flood impact provides change detection and flood mask based on the pipeline provided by Sachin, which is GeoDump, and the flood risk is exposing products mainly coming from Copernicus, which can be Era 5 land, GLOFAS, or other kind of products, depending on the area of interest and the specific hazard we are monitoring. The system is mainly composed by two instances. One, the developer instance, is for implementation, test, and validation of datasets and algorithm. And the second one is the production instance, which is for exposing the service to the public. This is the landing page that is already exposing the access to the front end and the access for the expert to the Jupyter lab, where Jupyter notebooks are expected to be uploaded as example. Now I want to go live in the development instance. Okay, here is the the instance. Maybe you recognize the layout already seen in the first pilot presented. Here, this is the customization where we are exposing the area of interest we are working on. The first one is Charpia, is the use case proposed by Sachin. The second one is Australia, and the third one is Darfur, which is a use case proposed by an end user, which is an NGO operating in South Sudan. Here, the use case provides an information box where we have identified the main events occurring in the past, which are subject of analysis. Going to the use case, the products list appears. As I said before, is product is a list customized for this specific hazard, which means that we have selected the sea surface anomalies products because this area is particularly exposed to flood events coming from sea level rise. Here we can select the, here you can see the refugee camp, which is the subject of a use case, which is monitoring by Sachin in terms of impact of flood events. Here I am selecting the first product, which is the precipitation. In the system is uploading the time series of precipitation regarding the last 10 days. I can select the day of the last relevant event here, and here we can see the data about precipitation, the end 1st of May, end of April, we had relevant precipitation, and but also with respect today in the last 10 days in Charpia we had relevant precipitation as well. Then I select the other product, which is the sea level anomalies. Again, the date is of the last relevant event is the 1st of May, and here we can see the sea level anomalies going up due to causing a flood event. These are data sets telling us that something is happening in this period, in this area, which we can see the effect by analyzing the impact product. In this case, we see the flood mask and the area impacted by the flood event 1st of May. We can see that the refugee camp has not been severely impacted in this case, even though some close area were flooded. And this is how the system works. For each different use case, we have different kind of products. In this case, this is another use case we are working on, is Australia. In this case, we have selected other products like precipitation daily area 5, surface runoff, and the potential population affected, as well as the other GLOFAS products. In Darfur, we are still populating the system with a selection of data. This is just to say that the idea is to do the work for the user, which is expected to not have specific skills in data in climate data and health observation data. We select for him the most relevant data sets that can be visualized, exposed, and downloaded by the system. And then I'm going back to the presentation. These are the backup slides in case of the demo went running, but fortunately we did well. The next, this is the third section. The next steps concerns both the technical implementation and use case evolution. The first is the implementation of the Jupyter Lab, where the idea is to upload, to deploy some examples of Jupyter notebooks, explaining how to interact with the APIs exposed by the system. Then, from the technical point of view, and the idea is to complete the algorithm of data fusion, combining together Sentinel-1 and Sentinel-2 for generating change detection product. And the last one is the deployment of the production environment, which is supposed to host only consolidated dataset and algorithm on CreoD's platform. For all concerns the use cases, as I said before, we have been contacted by an end user, an NGO, which is Conflict Management Consulting, operating in remote areas that are interested in exploring the capability of Earth observation and climate data and providing information product for those operators on field. In this case, we have already identified the area of interest and the period to be monitored, and we are uploading the data sets. Of course, we are also working on the business plan in cooperation with the GeoDump and in the dissemination activities. And this is the conclusion of the third section. Now, sorry, I was not in presentation mode. Now I leave the floor to Omar for the last section.
Thank you, Marco. Can you share my the screen during my presentation?
As you want.
If you can, I prefer you do it. I will tell you when.
Tell me just when I have to change the slide.
Perfect, thank you, Marco. First of all, I would like to introduce SATSEN. SATSEN is the European Union agency supporting the European Union in the field of the common foreign and security policy by analyzing data from space-based assets. And in particular, I'm working in the research, technology development and innovation union that SATSEN is using to implement new operational solutions looking at the whole Earth observation and collateral data lifecycle. So we are working in different topics like new data sources or Earth observation applications or cooperation. And please, next slide, Marco. Our main goal is to be able to address the decision makers' needs. So basically, we can summarize this when we talk about geospatial intelligence, is that the decision makers need to have the right information at the right time, to the right people and in the right place. SATSEN has been working on this for 30 years, so we know how to do that. But in the last years, we need to face some new challenges that that they are raising. Basically, these new challenges are related to data, technology, and scenarios. In particular, for example, for data, we now have a lot of big amounts of data, new different data sources, large constellations, new thermal imagery or radar imagery that we need to exploit to have the right information. To have the right information is to exploit at maximum the information that we have. Fortunately, for this, we have this new technology, and the latest technology related to big data, artificial intelligence, cloud computing is allowing us to exploit this new data. And with this data and technology, we can be able to address the new scenarios. Traditional security is always important, as we can understand the security as something related to military activities and so on. But in the last years, other topics like climate security and considering security as something that is affecting to the safety of citizens, it is more and more relevant, and we have to consider these new scenarios also as security. And if you go to next slide, Marco, an example of these new scenarios and complex scenario is one study we did that it is the basis also for our participation in this pilot. It was the case of the Rohingya people that were a crisis in Myanmar that resulted in a displacement to Bangladesh. And in Bangladesh, authorities built a refugee camp in Sharpija Island. That it is the one example shown by Marco. And this island is very prone to flooding, and also this flooding are being increasing more and more because of the changes in the seasonality of the monsoon period that is produced by the climate change. So basically, our first study on this was made in two phases. In the first phase, we monitor the construction of the refugee camp, and then we monitor the flooding over this island during a period of 4 years using Sentinel-1 and Sentinel-2 data. And if you go to the next slide, please, Marco. When we did this study, we noticed that we were not fully responding to the new users' demand for this. And that we needed to go one step beyond and innovate to have a final solution, an advanced solution for final users. And for this, we noticed that sometimes we need a better integration of resources in a simple way, control and friendly access to the results for final users. We have to consider that decision makers are sometimes expert users, but not always. So we have to be able to provide this kind of information to different kind of users. And this is the things that we try to address with Friend, is to have an intuitive and holistic and fast access to GeoInt products. If you go to my last slide, Marco. So basically, our experience with Friend, also as co-designer and possible user of this, is that Friend is allowing us to add value to the existing product. We have already seen some of the Sentinel-1 or Sentinel-2 masks of floodings, but this without any correlation with other variables, with more correlated variables, like, for example, the sea level or the precipitation amounts and so on. Sometimes it is not enough for the users. Also, we know that there are other points to access this other kind of data, but Friend is offering this single and friendly access point to this multiple data that we can configure and customize for the different users. So we think that Friend will increase the user community for our products, and also will facilitate the user uptake by allowing also the exploitation of this data by non-expert users that are usually the ones that are needing this kind of quick access to GeoInt products and so on. So this is more or less our experience with Friend. Thank you.
Thank you, Omar.
Thank you, Marco. Thank you, Omar. Okay, and now we should pass to the next pilot presentation. This is given by Alexia Masakan from One Earth South. It's about the Mountain Now pilot activity, a live map of mountain hazards for the Alps. And it will be followed by the testimony by Jean-Christophe Rochard, the tour leader from Swiss Alpine Club. Alexia, the floor is yours.
Thank you very much, Aris. First of all, can you see the full screen?
No, we see two screens actually, the main and the one that works. Okay.
Okay, so let's try it like this. And now?
Still the same.
Still the same, okay. So we'll do something more drastic. Okay, and now?
It's okay now.
Okay, all right. So it's a real pleasure to introduce this newly onboarded pilot Mountain Air. It's a partnership between Mountain Air, Applica Exolabs, and Planetech Italia. And it's about a service, really, a very much user-driven service. And the need that we are trying to address is really real-time geolocalized information about outdoor hazards, but beyond that, really overall conditions. And because what we actually found a few years ago was that this information is actually still very hard to get. So in the end, people like you and I going to the mountains do not have the information they need in order to be prepared as much, to be safe, quite simply. I mean, they don't know whether it's going to be, whether the bridges to cross rivers are going to be up, whether there is any snow to have to deal with, and so on. I mean, it can be also about real, and often about real hazards like rock falls or Serac. Actually, there was a major accident in Switzerland about 2 weeks ago about a Serac avalanche that killed 2 people and injured over 10 mountaineers. So this is a serious hazard we're looking at. And beyond individuals, we're really looking also at businesses and the public, the private actors involved in the tourism and the mountain sports realm in general, the national parks, the tourism offices, and so on. They miss the data in order to optimize the way in which they deal with the maintenance of their areas and the kind of sports activities that they can propose. So this is really where we want to be, and the impact is about thousands of lives and millions, in fact, as far as the industry is concerned. So our unique value proposition, I mean, it's a unique combination of crowdsourcing, satellite information. For instance, we offer a satellite snow depth distribution over the entire Alps, which offers a really nice complement to the crowdsourced information, which will tell you, what kind of snow you may have, whether it's powder, whether it's icy snow. And the satellite view will give you the overview with the actual depth that you may be able to find on your way. The real-time aspect is crucial: hazards location, the social network, the big data AI that we are gradually implementing, the GPS track sharing. So all of that is combined, and the 3 aspects that really make us unique is the combination of the real time, the geolocalization of all the information, and the unique database that we are building, which is fully organized around icons and hazards, so that you can just push a button and extract all the info that was collected over the past winter, over the past 3 winters, and so on. Our traction to date, we've been operational since 2017. We have over 25,000 users overall in Europe at this point of time. We have over 20,000 tracks and observations already shared. The platform is actually operational worldwide, but we've been focusing in terms of communication on the Alpine region so far, but the potential is there. We can very easily expand to any mountain range in the world. We are already working with authoritative organizations such as Alpine clubs and safety bodies throughout the Alpine region. And we are, excuse me, we are available in 4 languages already. We were talking about, making Mountain Air available in Greek, and I hope we make that one day. Rather sooner than later, and everything is free, and everything has been free until now. And this is a key point in the context of eShape, because one of our main objectives via eShape was really to move to the next level, also in terms of commercial exploitation, and to be able to offer a premium version of Mountain Now. And so we've been working on the new features that we wanted to offer, and today I'm able to show you a demo, an exclusive demo, in fact, of 3 of those new features that we have already implemented. So I'll move straight to that. The first one is I mentioned the snow depth before, but until now we've only had the current snow depth. And so now, thanks to our partnership with Exolabs, we've been able to integrate the 2-day forecast, which is a major added value, in fact, for anyone who's intending to go to the mountains. And the very nice thing about this feature is that you can click anywhere on the map directly with your finger, and you get the actual value of the snow depth. And so it's extremely handy, and you get that for the entire Alpine region. The second feature that I want to highlight is the smart filtering. So now you can actually enter a keyword for any track name which has been shared in the past. You can play with the time period that you're interested in, the kind of conditions, and the observation type as well. So this really, beyond giving you information about the latest hazards, this also takes you into the inspiration part, because if you want to find a safe hike for next weekend, for instance, you can go to last year at the same period and see what has been shared at the time. You can also filter on any type of observation, so that if you want to see everything that has been shared under the track label, you can do that and check the info that was associated with it at the time. For instance, you know that the path is not very well maintained, or it's really exposed, so you better be at ease with heights if you go along that route. And the last feature is actually the capability to be able to share a comment as you share a track. I mean, until now you could only share the track and give it a color, giving you an indication of the conditions that it had. Now you can record your track with a GPS. You can draw your track as just shown on the demo, and then at the end you can add comments as to really, I mean, giving a general comment. This is actually, we are actually directly responding to user requests that have been asking for that feature. So this is an illustration of the way we're going. Over the years, we've been developing very strategic partnerships that have helped us grow, and we continue doing that. The latest that I will emphasize are the ones with the Swiss National Monitoring Networks for glaciers and permafrost monitoring. And we've been able, through the financial support of Meteo Suisse and GCOS, the Global Climate Observing System, to run a major observation campaign over last summer, and to collect observations that are directly relevant to disasters management and adaptation to climate change. So for us, it was an important milestone, because our initial focus was really on mountain safety and enable individuals to get as much information on the latest hazards and conditions. And with this observation campaign, we really moved more towards the more citizen science potential of Mountain Now, and serving research and adaptation to climate change directly. And this is to clarify that, in fact, everything, I mean, to clarify the potential that Mountain Now has, because if you think of it, the whole infrastructure that we have developed in terms of, you know, all the features, the crowdsourcing, the combination with the satellite, the GPS tracking, and so on, everything offline. I mean, you can play with it offline as much as you want. You could apply that. We focus on mountains right now, but you could apply that to the sea, to rivers, to, you know, to even pipeline monitoring. I mean, the sky is the limit as far as the number of applications that can be developed, basically using the same infrastructure. And so now, Harris, if this is okay, I will move to the end user testimony.
Yes, of course, Alexia.
So Jean-Christophe Rosson is a tour leader of the Swiss Alpine Club, which means that he has the responsibility to organize, to plan, to decide who may be invited to the tour or not, the kind of equipment and so on. So it requires a lot of prerequisite knowledge before actually taking people to the mountains. And he also has a very much group, club, association view, which is important, and also beyond representing environmental services as a whole. So I'll let the. What is innovative about Mountain Now?
Thank you, Alexa, for giving me the opportunity to talk about Mountain Now to change with you today. Well, for me, what is innovative, maybe it does not sound innovative, but it is ease of use and convenience. This is what I believe are the key values, the key benefits. You can do that using the mobile application. Personally, I prefer using the web app for this purpose. More generically, I would say you get what you need. It's simple, everything is geolocalized, and the possibility to enrich the content with pictures, when pictures typically say more than 1,000 words, that's exactly what you need. You know where things are happening, and yes, you can put a description, but you can get a picture and get the information in very easy. Other things that I like with the system come together with topographic cards, maps, and it's clever enough to choose the best available map for the region where you are, for Switzerland, for France, for Italy, for my case, and you don't need to bother switching to the map that is available for this region. The system does it for you. There has been as well recently some new layers of data that have been added that I find convenient. The slope, the presence of snow, the depth of snow, all information that are very convenient when I'm trying to assess are the conditions today good for this tour or that trip.
Excellent, thank you for that. I mean, you were talking about pictures and maybe would you have maybe a couple of examples to give us of situations where you felt where that Mountain Now was particularly useful, or maybe to alert of a danger?
Yes, I can think about several. One of them would be finding the start for a climbing route. Very often, the last meters are the most difficult. Maybe a typical use case would be to know about the current state of a glacier and its crevasses. I could give an example with the Weissmiss. It's normally an easy route, but I would really recommend that you have a look at the state of the Trist Glacier. That's the name of the glacier there. The crevasses there are simple when the bridges are in place, but they are very tricky when the situation degrades. And having somebody sharing through Mountain Now the state of the routes when you're planning, that's just very useful. You know how many hours you will need actually for the path there. Another example, maybe in winter, more and more we see during the winter conditions that were rare in the past. I can imagine, for example, on a steepy path, a very icy condition of snow, so icy that actually you can't glide on it with skis. You actually do glide, but you lose control and fall. That's the kind of thing that, in that case, might not be easy to see visually when you're there. So never with a picture, but you can report that actually this location is dangerous and should be avoided. I had the case this winter, and really this is a case that is stunning.
Harris, there is another 2 minutes of the interview. Should I play this, or do you think we are?
Yes, please go on. Yes, Alex, of course.
Another key feature of Mountain Now is, as I said before, the ease of use, but as well the fact that the information becomes immediately available to the community. This community can be, yes, mountaineers, but it can be any population or group of interest that needs this information to take adequate decision. So it could be the authorities as well.
Yeah, that's very true. In fact, we work with national parks authorities, and we could imagine that civil protection could be interested in some of those real-time information as well. Well, thank you very much for this insight, Jean-Christophe. Maybe the last question. You described very well, what is available at this point of time. Maybe thinking of the future in your view, and maybe from the Swiss Alpine Club perspective. How do you think? How would you improve Mountain Now?
Well, I think there are already a lot of features in the tool, so it's probably more on the contributing side that I would wish a broader spectrum of information to be available in the tool. For example, I would wish that more authorities or tourism offices or maybe guide offices would use the tool. Some do already today, but not all. Very often information gets reported by regular Mountain Now users, contributors to the community who share what they observe on the field. But that's a second-hand information compared to having directly the entity that decides about closing that or that route reporting in the tool. I could think as well that Mountain Now could benefit to be maybe more reported on some other website and web services used broadly by the mountaineer community, so that more people know about Mountain Now and more people start contributing as the broader of the community, the best the value of Mountain Now is.
Very good points, indeed. So rather than the technical side itself, it's more on the actual communication and practical use of the tool that you would put emphasis. Well, thank you so much for those comments, suggestions. Highly appreciated. Thank you, Jean-Christophe.
It was my pleasure. Thank you very much.
Thank you, Alexia, and thank you, Christophe. At this point, we reached the end of the presentations according to the agenda of the day. And I would like to give the floor to any of the participants who may raise any question. Alexia, I don't know if we have collected any questions in the Q&A window.
No, we don't have in the Q&A, but we had in the chat, and some of them are already replied on the chat by the respective.
Okay. Actually, I had one more question. No, I have several questions, but I don't know how much time we have available. But anyway, there was a question first to Antonio from Chima, because I mean, I did see something very impressive there in their systems, in their models forecasting medicanes and also providing flooding awareness at local scale. I was considering, and that's of course after having listening to the testimonies of the Civil Protection Authority of Italy, I would like to know if Antonio is still with us. What is the possibility that this system is transferred to other Mediterranean countries, in South Mediterranean or North Mediterranean? But anyway, I mean, in neighboring countries that as I understand, the WRF models are could provide weather forecast. Antonio, if you are with us, could you please elaborate a bit? I mean, if it is possible to, because I mean, between the scopes of ESAPE, and this is something that I would like also to ask all the presenters today, that is Eurogeo initiative, and especially the ESAPE project is actually trying to co-design and co-develop with users something that could be transferred, could be used, so that the investment of EU in Copernicus and in DIAS platforms and all this that Commission has been investing into for the service delivery development is something that it is used to the maximum possible extent and scale. So, I mean, Antonio, could you please elaborate a bit on that?
Yeah, can you hear me?
Yes.
I'm here. Okay,
Yes,
okay. No, because I did change headset, so I was not sure if they are working. Yes, concerning the portability of the system, in principle, from a technological point of view, let's start with the wharf part. It is portable by construction, in the sense that whenever we have access to the global circulation model data, in our case, we are working currently with GFS because they are available for free, but potentially we can also work with IFS. This part is very easy to manage. The data assimilation part requires to have access to local data. They can be, as we saw, from the in-situ weather stations or from radar data, or in some cases also from the Copernicus products for the meteo part, even if this is not always easily digested by meteo forecasters, because we are willing to have correctly a stable set of input data to be assimilated. And we know that the Copernicus products, especially the Sentinel-1, have a certain revisiting time that can make challenging to have them constantly in space and time. But technologically, yes, we are there, we can make it. The hydrological part of the story is the same, in the sense that whenever we have data, observational discharge data to calibrate continuum or another hydrological model, this is feasible. One thing that we had in mind is the fact that we would like to, hopefully with new funds, to test the system not only in the Mediterranean area, where honestly there are a number of very good weather services, and in that case the idea more than transfer our WRF model is to transfer the idea, the results to be further exploited there, where we are probably more opportunities to set up some things from scratch is, for example, in Africa continent, where apart for a few exceptions like I don't know, South Africa or maybe Kenya, where there are very good and established weather services, in other parts the situation is, for a number of reasons that we know very well, much less good. And in those places where we don't have so many in situ observations, because the ground-based weather stations are not almost available, the radar data neither, at least for the hydrological and hydraulic part, exploiting the Sentinel data to calibrate and drive the hydrological modeling continuum or the Telemac-1 can be absolutely an idea. So in making the story short, the answer is yes, it is portable. In the Mediterranean environment, the issue is to establish the proper data pipeline with in situ observation. In other countries, like in Africa, the problem is probably to have stable and decent computational facilities to do so. One idea that we are exploring at the moment, only for the wharf part, is to move some of those concepts in Sudan, where the Italian government has established a cooperation through the Ministry of Foreign Affairs. And there we'll help local experts in setting up a wharf model for daily forecast. First of all, without assimilation, just baseline with GFS. But colleagues from the hydrological department at CIMA will establish for a certain portion of the Nile River, the continuum model, exploiting the Sentinel data as an input, and there can be a good test bed.
Thank you, Antonio. Thank you very much. I know that you want to say much more, but I have one last question for Alexia before we close. For this very interesting application, the mountain now that so mature and so much used already by the users. Alexia, I wanted to ask you, do you consider the ESAPE project and the EuroGeos initiative in general as a forum where you can make your application known and as a forum that can help you, support you in developing further the applications, reaching out more users, or even and other areas of applications, not only the alpine areas and the snow covered areas, but also some other recreational, I don't know, I mean, areas that are, people used to go and need some information.
No, absolutely, Harris, and thank you for making that point. This is exactly what we're trying to do. I mean, developing the premium version obviously is instrumental in the context, but beyond that, until now we've been really focusing, as mentioned, on the Alpine region and on the mountain realm. And as you maybe saw, our strategic partnerships are very much sort of constrained, so to speak, to that to this geographic area and thematic area. And through eShape, for us, it's really an opportunity to expand on network, explore new opportunities in the mountain context. I mean, I'm really hoping that, vis-a-vis Greece, for instance, we are actually able to get known, and because rock climbing, in fact, is very popular on mountain now as well. So it's just one example, and in terms of expanding thematic areas, I mean, we've been working within the context of the one of the work packages to really explore, and cultural heritage, for instance, is something where we see that mountain now could be very easily applied. You just adjust the icons basically as you share an observation, and the whole geolocalization and the crowdsourcing, the real time, the database, everything is already there. So that's what we are doing actually right now, and it's part of expanding our community and looking into the future. So it's exactly what we're trying to do in the context of eShape. And in fact, I invite anybody listening or with any ideas, wild ideas potentially as well, to get in touch with us on info@mountainair.net.
Yeah, thank you. Thank you, Alexia. Before we close, I wanted to ask any of our presenters or participants if they want to comment anything, take the floor to say anything about the experience you get out of the ESAPE and the pilots that you are running, or the pilots that you heard about today. No, I don't see any reaction, any volunteer in taking the floor. So then at this point, once again, thank you very much. I really enjoy working with you, my dear colleagues, with actually now 6 pilots in this showcase, and I do believe that ESAPE and all our action is something that helps you in developing further your activities, innovation activities, or research and innovation activities, and give you the opportunity in making, building, innovation, businesses, whatever it's your prospects and scopes. Thank you very much, and thanks all for your participation and attendance, and keep in touch. Have a nice day.
Thank you.
Bye.
Thank you.
Thank you. Have a nice day.
Everyone, thanks.
Thank you. Bye-bye.
Bye.
Bye, everyone.